Hello, everybody. Mr. Lake here once again with another Math Bootcamp video. In the last video, we discussed significant figures, where they come from, why they're important, and how they're based in measurement. And today we're going to talk about how they are related to rounding. Because have you ever done a calculation and you've plugged into your calculator and you've gotten some crazy, ultra long number that you don't even know what to do with? You get like 22 decimal places or something like that. And you're like, I don't know where to stop this number. Where do I stop writing this down? And in those situations, up until this point, the answer's probably been, I don't know, just write numbers until you run out of room, or ask the teacher, and the teacher will say, keep 3 decimal places. And you're like, okay, I'll just keep 3 decimal places and ignore the rest of those numbers and pretend they don't exist. There's a better answer to that question, and it has to do with significant figures. Significant figures is what tells us where and when to round. So let's get into it. First of all, why do we even round? Why don't we always keep numbers as long as we can? Why don't we keep an entire number as long as the calculator spits it out for us? Well, it's because it has to do with accuracy. Remember, numbers and significant figures are all about accuracy. So, for example, if you are taking a measurement with a ruler and you can measure down to you can estimate down to the hundredth of a centimeter. So you say that, something is 4.25 centimeters long or something like that. And then maybe you go and you do some statistical analysis on your measurements. You use that number in a calculation and you do a calculation and you get an answer of like 18.7849362104 centimeters squared or something. You can't keep all those digits because that answer is way more accurate. It goes much, much further, has many more decimal places than the original measurement. And so rounding makes sure that our final answers that we get to calculations, or our final outcome, maintains the same level of accuracy as the original measurements that we took. The reason that you have to know these rules about rounding, and you actually have to know them in your own brain, is because calculators do not do significant figures. I have yet to find a calculator that has a sig fig function that you can turn on and it will do all of the significant figures for you. Maybe they exist out there. Maybe I'm just unaware, but it's definitely not a standard feature on calculators. And so you have to know significant figures and rounding yourself. So let's cover how rounding works. And these might sound familiar. You've probably rounded numbers before. Basically, the way that rounding works is that you're going to go to the last number or the last digit that you're going to keep. And in this case, it's going to be the last significant figure. So let's say, and I haven't gone over the rules for how to determine this yet, I will. But let's say that you determine that you get to keep 4 significant figures in your answer. So you're going to go start from the left of the number and you're going to count the first 4 significant figures. And that fourth significant figure is going to be your last significant figure that you get to keep. Then what you're going to do is you're going to look at the number to the right of that last significant figure. If that number is either equal to or greater than 5, then you round the last significant figure up. If it is less than 5, then you round it down. Or in other words, you don't change it. Let's do an example. Let's say we want to round the number 2.532 so that it only has 3 significant figures. This currently has 4 significant figures. Let's say we determine that we can only keep 3, so we have to cut out one of those significant figures. What we're going to do is we're going to follow that rule I just gave you. We're going to start from the left. We're going to say, okay, this is significant figure 1, significant figure 2, significant figure 3. This is going to be the last number we keep, right? The number is going to stop after this spot right here. But before we just cut it off and forget about the rest of it, we have to look at the next number to the right. In this case, it's a 2. 2 is less than 5. So this 3 is going to round down, or in other words, it's going to stay the same. And so what we get is that this number would round to 2.53. Now, what if it was 2.536? Well, the 2 is the first sig fig, the 5 is the second, the 3 is the third, and we're still rounding to 3 sig figs. So the 3 is the last digit that we're going to keep. But we look at the next digit to the right, it's a 6, which is greater than 5, and so therefore that 3 is going to round up to a 4. So this number becomes 2.54. So we've already gotten to a point where you can continue working on that significant figures rounding and scientific notation worksheet. Specifically, you can now work on section 2, which just gives you some numbers and tells you how many significant figures you get to keep, and you just have to round each of those numbers and practice that skill. So if you want to pause the video and work on section 2 and come back to this video in a minute, go for it. But if you are still with me and you want to just keep learning, then just keep learning. I'm going to go over now, how do you actually know how many significant figures you get to keep? Because in those examples, I just said keep 3 sig figs. But where did that come from? Where did I get that? There are rules for determining how many significant figures you get to keep in your answer. I have some good news and some bad news. The good news is that rules are good because they don't leave much space for interpretation. They don't leave many unknowns. If you know rules for how to do things, that means that you know exactly how to do something and you don't have to wonder whether or not you did it right. The bad news is that rules are sometimes hard to remember. And in this case, there are different rules. There's 2 different rules, one for multiplication and division and one for addition and subtraction. Let's do the multiplication and division rule first. When you either multiply or divide numbers, the answer that you keep must have the same number of significant figures as the original measurement with the fewest significant figures. Feel free to pause the video if you need to finish writing that down. But let me give you some examples to hopefully help this make a little bit more sense. Let's do this first number here, or this first problem here, 24 times 3.259. And I'm just going to plug this into my calculator, 24 times 3.259. And the answer that I get in the end is 78.216. That's the full number that my calculator gives me. Now I have to question, do I get to keep that whole number? I'm going to give you a hint. The answer is no. In order to determine where to round this number, what I've got to do is I've got to go back to the original measurements and figure out how many significant figures does each of these have. Well, 24 has 2 digits. Neither of them are 0. So they're both significant. So there's 2 significant figures here. 3.259 has 4 digits. None of them are zeros. Therefore, they're all significant without any having to use any complicated rules. There's 4 significant figures there. My answer can only have significant figures equal to the number of significant figures of the original measurement with the least. So in this case, I can only keep 2 significant figures, which is going to be the 7 and the 8. Therefore, I have to look at the next number to the right of the 8 and see whether it's greater than or less than 5 or equal to. It's less than 5, so the 8 is going to stay the same, and my final answer is 78. Also, I'm just going to throw in there, units are really important. We're focusing on numbers right now, but don't forget that units are super important, and this would be meters squared. Go ahead and pause the video, do these other 2 calculations. I'm going to stop talking for about 5 seconds so that you can pause the video and do those, and then I'm going to give you answers to them. All right, I hope you stopped the video and did those on your own. Let's go through these examples. 1,227 meters times 0.10 meters Plug that into my calculator. 1.1227 times 0.1. I didn't need to plug that in my calculator. What am I doing? 122.7 meters squared. How many significant figures do I get to keep? Well, this number has 4. This number, oh, this is tricky. There's a leading zero. Leading zeros are never significant. This 1 is definitely significant. And then this trailing zero is significant because there is a decimal in the number. So this number has 2 significant figures, which means I get to keep 2 significant figures because that's the least of these 2 numbers. This answer can only have 2 significant figures. Now, what are we going to do? I chose this example on purpose because this is where a lot of people get confused. We get to keep the 1 and the 2, and we're going to look at the next number, which is less than 5, so the 2 is not going to round up. So our 2 significant figures are 1 and 2. Now, is our answer just 12 meters squared because those are our 2 significant figures? Absolutely not, because significant figures is just changing the accuracy of the number, changing how many sig figs it is. It's not changing the whole number. We're just rounding here. So we can't round 122.7 to 12. That's not even the same number at all. Instead, when you end up with a situation like this where your significant figures, basically you have less significant figures than there are places before the decimal, you need to use what are called placeholder zeros. So this 1 is in the hundreds place here, right? And this 2 is in the tens place. They need to stay in the hundreds place and the tens place. And so we need to put a 0 here to fill in that space so that the 1 is in the hundreds and the 2 is in the tens, but the number still only has 2 significant figures. So this is going to be our final answer. Now let's do one more. 4.849 divided by 2.45. And we get 1.979. 1.83673 meters per second. Teacher, how many numbers do I keep in my answer? Right? I don't want to write all that. Well, you don't have to, because again, we're going to keep the least number of significant figures. This number has 4 sig figs. This number has 3. So we're going to keep the first 3 significant figures here. The number after the last significant figure is a 9. Therefore, the last sig fig is going to round up, and our final answer is 1.98 meters per second. Good work, everybody. That is the first of two rules that you need to know about knowing where to round. Here's the second rule. This one is for addition and subtraction. When you add or subtract numbers, the answer that you have at the end must have the same number of digits to the right of the decimal, not significant figures, digits to the right of the decimal as the original measurement with the fewest digits to the right of the decimal. So we still have this, like, look at the original measurements and keep the fewest, but we're not looking at significant figures. We're looking at just places to the right of the decimal, which you might be thinking, and you'd be correct, that means that you keep everything to the left of the decimal place, no matter what. You only are going to be limited in what you can keep on the right of the decimal. Let's do an example. Let's say we added these 3 numbers, and you get that number. Now, to know where to round this number, what we've got to do is, again, not look at how many significant figures are around. I'm going to switch. I'm going to use a cool green color. Yeah. So we're not looking at overall significant figures. We're just looking at how many spaces are to the right of the decimal. This number has 1 decimal place to the right. This number has 3, and this number has 2. All right, 1, 3, 2. Which one of those is the lowest? That would be the 1. So we only get to keep 1 decimal place. And then once we know where we're going to stop our number, we follow the same rounding rules. We look at the number to the right, Is it greater than or less than 5 or equal to it? It's less than 5, so the 2 is not going to round up, and our final answer is going to be 77.2 centimeters. So there you have it, everybody. Those are your rules for rounding for chemistry and for science in the future. I hope you paid attention because if you ever take any more science classes, these are going to be really useful skills. You are now cleared to not only do sections 1 and 2, but also do section 3 of the significant figures rounding and scientific notation worksheet. As always, let me know if you have any questions. Take care of yourselves, and I will see you in the next video.